So yesterday we were talking about taking a region that was not fully pushed up against the x-axis and then revolving it around the x-axis. And instead of giving us disk or circular cross sections, it gave us washer cross sections. Right? Circle with the circle cut out of it. Everyone remembers that? Pi times the outer radius squared minus pi times the inner radius squared gave us the area of that cross section. So we just integrated it times the dx. Yeah. All right, so we're going to take a look at this one. Yeah, very similar problem. We're just going to do probably just this one, and then we're going to move on to moving around other axes. Because there's not a whole lot different with this than what we were doing before with just revolving, other than you got to subtract something. So it's making weird noise. You guys hear those weird noises on Zoom?
Yep.
Yeah, it's crazy. I don't know what that's all about. All right. So we're going to look at the region between cosine x and sine x in the first quadrant. We're going to look at this first little region here. So we're just looking at this one. I know there are other regions bounded by cosine x and sine x in the first quadrant, but we're just going to look at this one. We're going to take that and revolve it around the x-axis. So we're going to get down here some sort of blue-looking thing, and over here some sort of red-looking thing, and we get, oh, that's supposed to be red, it didn't change the color. But as we go around the x-axis, there's a big gap in the middle of it, right? The region that we're revolving around is not fully pushed up against the x-axis, so that when we slice this vertically through there, we end up with a big circle with a smaller circle cut out, right? And so we've got to find the outer radius, we've got to find the inner radius, we got to square them both, multiply them both by pi, and integrate. In this case, where are we going to integrate from? Talking first quadrant, so we're going to start at 0, and we're going to integrate to here, right? Where is that? How do we know what that is? How do we know what that is? What? Yeah, how do we know that?
It's when cosine and sine equal to each other.
Yeah, set sine equal to cosine. That happened 5/4. If that's the first time where sine equals cosine. So it becomes the integral from 0 to pi/4. What's your outer radius? Which one of these functions is above the other one on this interval?
Cosine.
Yeah, cosine, right? Cosine, it starts at a maximum of 1. Right? So cosine is above sine. We're going to have cosine squared. And then we're going to have sine squared. We're going to subtract. Everybody good with that?
Why do we square?
Because remember that the area of the outer radius, or the area of the outer circle, is pi r squared. And the area of the inner circle is also pi r squared, just its radius.
Thank you.
Good or no?
Yeah, and the height is cosine, that's right.
What?
And I got it.
Yeah. The radius is the height of the function. Yeah. Everybody good with that setup? Okay. How are we going to integrate cosine squared minus sine squared? What do you mean? Why is it only a small portion of it? Why did I only just do a little bit of it? Because I just wanted this region. So I just didn't need to sketch any more of it. Any thoughts on how to integrate cosine squared minus sine squared? Cosine squared minus sine squared, that'll look familiar to you. All right, we're going to go back once again to remember that piece of paper that I posted and told you that you should memorize. It says required trigonometric identities. You guys all remember that paper? There's one on there about cosine squared minus sine squared that you should memorize and know and be able to utilize. What is cosine squared minus sine squared equal to? Cosine 2x. So this becomes pi times the integral from 0 to pi/4 of cosine of 2x dx. Good or no? Yeah? Okay. How do we integrate cosine of 2x? U substitution. Now, if you can do the U substitution in your head and keep it all in terms of x, that's great. Comes out to be 1/2 sine 2x. Awesome. You can do that. If you can't do that, that's fine. I suggest you get to the point where you can just sort of manipulate it in your head and figure it out. But if you're struggling with that, just do the U substitution. U equals 2x. du equals 2dx. So 2, 1/2. Right? And then we change the integral. It becomes pi over 2 times the integral of cosine u du. And instead of going from 0 to pi over 4, we go from 2 times 0 to 2 times pi over 4. And then we integrate. And it out. Good? People at home good?
Yeah.
People here good? Yeah, right there, Riley. You look. Because these are in terms of x. And this is all in terms of u. So we have to convert the limits from x values. Good? All right, so what's the integral of cosine u? Let me go back to that in 1 second. Let me just get the final answer. We get sine u, and then we evaluate. We get pi over 2. Sine of pi over 2 is 1. Sine of 0 is 0. So we end up with the final answer of pi over 2 units cubed. Everybody good with that? The arithmetic at the end? Question on the arithmetic? Before I have something. You could turn it back to sine 2x if you wanted to, but then you have to turn the limits back to 0 and pi.
Right. So I just went could you go directly from cosine? Okay.
Yeah, that's what I say. If you could do it in your head, just leave the limits and just do the integral in your head and keep it. That's quicker and easier. That's what I would do, but some people have trouble with that, so right up. Okay, so Ryan, to answer your question, why do we square them? Well, because remember, we're looking for the area of the outer circle. That's pi r squared, capital R squared. And then the area of the inner circle is pi, its radius squared. And so the radii are the height of the function and the height of the other function, which are cosine. Good? I mean, it's the formula, had this formula yesterday. Everybody here good with that problem? Yeah. Everybody at home, you good with that or no?
Good.
Yeah.
Yeah. Okay. Let's do one more. I wasn't gonna do one more, but I feel like we could use the practice doing one more. So let's do one more. All right, let's take a look at. We're going to look at the region. Let's see, what region do we want? The region between, how about, y equals x squared and y equals about 2 minus x squared. Let's say the region between that in the first quadrant. Around the x-axis. Sound good? Yeah. Everybody at home good with that?
Yeah.
Yeah. Okay. All right. Let's sketch a graph. There's y equals x squared. There's 2 minus x squared. And we're taking the region in the first quadrant and revolving it around the x-axis. So we're looking at this region right here. Is that region fully pushed up against the x-axis? From the furthest left point of the region to the furthest right point of the region? No. Right. This point over here is, there's a big gap in there. Right? So first thing we're going to need to do is figure out what the limits of integration are. So if we're talking just the first quadrant, we're going to start at 0. And then the intersection point of x squared and 2 minus x squared, right? So how do we find the intersection point of x squared and 2 minus x squared? Set them equal to each other. So we'll say x squared equals 2 minus x squared. That gives us x squared equals, add and divide, x squared equals x squared equals x squared equals
1.
1. Yeah, you guys know how to solve basic algebraic equations, right? Okay. Just making sure. So if x squared is 1, then x is positive or negative 1. Yeah? If we're talking first quadrant, then we should be talking x equals 1. So integral 0 to 1, pi on front of everything, the outer radius squared. So which one gives us the outer radius? Which one is the upper function? 2 minus x squared. 2 minus x squared squared. And then minus my inner radius. My inner radius is x squared. So minus x squared squared dx. Everybody okay with that setup or no? People at home, are you good with that setup?
Yeah.
All right, now it's just algebra. Pi 0 to 1, 2 minus x squared squared ought to be what? 4 minus 4x squared. And then we're going to get a plus x to the fourth. And then that's going to be a minus x to the fourth. So those will cancel out. You can ignore that. This dx. So we have pi. We get 4x minus 4/3 x cubed from 0 to 1. Good with the integration? Good with the setup? All we have left is arithmetic. Pi times 4 minus 4/3. 4 is 12/3, so 12/3 minus 4/3 is 8/3. So 8 pi over 4. Good. Good or no? Yeah. They're not going to require you to do that on the AP test. I just sort of am in the habit of doing it. I'm not going to mark you off if you don't write units. If they want units on the AP test, they will specify indicate units of measure, and there will be some sort of units given to you in the problem. They'll give you inches or miles. Any other questions? Did you guys hear the questions when people asked them in the Zoom? If people in the class asked?
No.
No, but you can hear me saying things.
Yeah.
Okay. If you're ever confused about why I'm rambling about something, you can let me know and I can explain. Cool. Good talk. All right. How do we feel? We want to do another one or we want to move on to something a little bit different? You guys need to do another one? Should we do another one? Did you guys do one on your own? Maybe you do it on your own? Let's have you do it on your own. I'll come up with a fun one. Come up with a real fun one. You're going to love it. It's going to be great. Let's take the region between, how about let's just go between x squared and x cubed in the, let's say in the first quadrant again. And then we're going to revolve that around the x-axis. Find the volume. So be careful with your sketch of your graph. Make sure that you have the correct function above the other one. Make sure you have the right outer radius and the right inner radius. I'll give you guys 3 or 4 minutes here to work on it. That sound good? Yeah, yeah. That sound good, Zoom?
Yeah.
All right, have fun. There we go. All right, region between x squared and x cubed. X squared and x cubed in the first quadrant look actually fairly similar, right? There's one of them. We'll call that one x squared, I guess, and then I don't like how I did that. We're gonna do this again. We're gonna try and do this again. There we go. Okay. Here's x squared. That's better. Huh. What does x cubed look like? Is x cubed above or below x squared? Below, right? X cubed looks like this, right? We should know that x cubed is less, because if you take a number that's between, let's see, where do those intersect? When does x squared equal x cubed? 1.
1.
Take a number between 0 and 1 and square it, like you take a half and square it, it gets smaller, right? Half squared is a fourth, but a half cubed is an eighth, which is smaller than a fourth, right? The more times you multiply that number by itself, the smaller it gets. So the x cubed values are going to be less than the x squared. So we're just going to take this little sliver of a region there and revolve it around the x-axis. So your setup hopefully should have been pi, integral 0 to 1, x squared minus x cubed squared dx. Everybody good with that? Everybody here in class good? Everybody at home in Zoom good?
Yep.
Wonderful. All right. Pi integral 0 to 1 x to the 4th minus x to the 6th, and then you just integrate it, right? X to the 5th over 5 minus x to the 7th over 7. 0 to 1. That's going to give us 5th minus the 7th times pi. What is that? 236, 2 pi over 35. I can still do fractions. That's great. Even better than when I was in 6th grade. Everybody good there? All right. Feeling good? Everyone's feeling good? Everybody ready for me to like destroy your worlds here? Yeah? Like make things more complicated and more difficult and all that fun stuff? All right. Here we go. Read that. And then we'll talk about it. Let you read it first. Maybe draw the picture. 2 pi over 35. You play an instrument too? Yeah. What do you? Oh, percussion. Okay. All right. Lots of different things then. Got like a whole band here. We have the percussion, we got the viola, we got the trombone. Anybody else?
Ian plays sax.
Who plays sax?
Ian.
Ian plays it. We get the saxophone in here. What are you playing? The what? Guitar. That's great. You know, we gotta get you guys to like switch. You could switch into the hybrid model, bring your instruments, and then we could rock out. It'd be fun. You bring an extra mouthpiece, and I can learn to play the trombone again. I'm not gonna share your mouthpiece. That'd be weird. But you bring a different one, I'd try it out.
I have multiple. I'm not letting you play mine.
You won't let me. You won't let me play your trombone.
Not my good one.
You have multiple trombones?
I've been playing for a while.
Since 6th grade?
4th.
4th grade? You must have not been able to reach anywhere in 4th grade. Huh.
I didn't say I was good in 4th grade.
You didn't say you were good now.
That is true.
I know, I walked by and then I came back by a couple minutes later and you were gone. You must have, I don't know. I was excited to hear how it sounded, but it disappeared.
We were behind the math building. We were told to move there because there was supposedly shade and there was no shade.
I see. It was too hot yesterday for your outdoor tromboning. Hey, you guys got this right now? We ready to talk about this? Is that a yes or a no? Yeah? All right. Not quite? 40 minutes. We're doing great. This is awesome. Okay, we have this function 3 times the square root of x over 4. And we got a region bounded by that, bounded by the x-axis, and bounded by the line x equals 4. Okay? We're going to take that region and we're going to revolve it around the line x equals 4. Okay? So if I take this region and revolve it around this x equals 4 line, I'm going to get something over here that looks pretty much the same, right? Going to get sort of a 3-dimensional shape. Looks like a little chocolate chip or something, sort of, yeah? So like that. Yeah, like a chocolate chip. That's what we're going to go with. And if I were to take my trusty geometric solid slicing knife and slice it vertically like that, and open it up, what's it look like? It's hard to say, right? It kind of looks like some sort of like maybe parabolic sort of shaped looking thing or something, but nothing that we know the area of really easily. Would you agree? And this is not going to help us out. We don't want to slice it this way. What if I were to slice it horizontally? What is each of those cross sections going to look like?
Circle.
Should look like a circle. Right? So we are now revolving around a vertical axis, which means that we have to slice it horizontally. If we slice it horizontally, we're going to get these discs that are very, very thin in which direction? The y direction. So these will be the thickness of dy, which means we're going to have to do every integral that we revolve vertically in terms, well, around a vertical axis in terms of y. Yeah. I just said we're going to. Yeah. Yeah. I'm going to take regions and revolve them around all sorts of lines. Yeah. It won't always be the x-axis, or we haven't done it with the y-axis, but it won't always be the x-axis or the y-axis. It'll be any sort of line. Any sort of horizontal or vertical. We won't be revolving around any like diagonal lines. Like, we won't revolve around y equals x. It's possible to do that, but it requires a lot more knowledge than we have for this time. We're just going to revolve around horizontal. Okay, so we're going to do everything in terms of y. Well, what do we need to figure out then? We need to figure out the radius. Isn't that the radius? True? The radius of that circle, of any of these circles, is going to go from the function to the line x equals 4. Do you all agree with that? And we need to figure out what the radius is in terms of what variable? We figure out the radius in terms of y. Because we got to do everything in terms of y, because it's dy. We sliced it horizontal. All right, well, in order to figure out the radius in terms of y, we're going to pretty much always have to figure it out in terms of x first. And the most important thing to remember about when you're looking for these radii is that x is always measured from the y-axis going to the right to some value of the function. So we're going to say that this little tiny piece here that I've drawn from the y-axis to wherever we're hitting is x. And what is the entire distance from the y-axis all the way over to the line we're revolving around? 4. So that should tell us, just by looking at that, what the radius should be. What should the radius be? It ought to be the full 4 minus that little bit of x. No matter where I go over to, if I go over to here and call this x, right, the radius at that point is still 4 minus x. Do you all agree with that? People in Zoom, you good with that?
Yes, but what happens when you go past 4 and the radius becomes negative?
It never does because we're only talking, remember, I don't know if you guys can see this yellow, but we're only talking about this region right here.
Oh, yeah, okay.
Right?
Got it.
We're not going to have any values over here. This is just what we get when we revolve it. And that's still, yeah. Our diameter extends from here to here, but our radius is only in that region. Does that make sense?
Yeah, thank you.
Everybody good with that? All right. So if our radius is 4 minus x, how are we going to write that in terms of y? Because that's what we said we needed, right? In terms of y. How do we get it in terms of y?
Find what x equals and then plug that into the equation.
Take our equation, right? And just figure out what x is. So if y is 3 root x over 4, then now it tells us that y over 3 is root x over 4. And that would tell us that y squared over 9 is x over 4. And that would tell us that x is 4y squared over 9. Everybody agree with that? Everybody here good? Zoom, good?
Good.
Okay.
Could we also do it like solve for x using the r equation and then plug that into y equals?
Solve for x using the r equation, and then yeah, you could do that. That's fine.
Like do 4 minus r and then plug 4 minus r into y equals 3 times the root of x over 4.
And then solve for r. Yeah, you could do that.
Okay.
I wouldn't recommend it, but it will work. It's generally going to get you worse algebra, I think.
Okay.
I think it's better to solve the equation in the original equation for x and then plug it in. But your choice. Okay, now we're going to integrate. Let's see, we have circular cross sections, so the areas of those should be pi r squared. We're going to put pi. And we know our radius is 4 minus 4y squared over 9. And dy. What are our limits of integration?
Zero to 4.
All right, I'm going to agree with 0.
3.
I'm not going to agree with 4. Why is it not 0 to 4?
Because that's the x and we're doing y, so it's 0 to 3.
Right, 0 to 4 is in the x direction. We've got to go 0 to whatever that is, right? And we can figure out what that is by plugging in 4 for x. And so if we plug in 4 for x, that's just 3. We're going to integrate from 0 to 3. So very important. If you're doing it in terms of y, do not forget that it has to be from the lowest point of the region to the highest point of the region on your limits. Everybody good there? All right, this is going to be a lot of arithmetic. It's a fairly easy integral once you square it out, but it's a lot of annoying algebra and a lot of annoying arithmetic to come up with it. We could do it. We could get an exact answer, but let's practice using our calculators once more to evaluate this integral, because I think that's good to be able to do too. So somebody tell me the approximation for this integral. Don't forget the pi on in front. Got your calculator at home. I bet none of the people in Zoom forgot their calculators at home. Didn't forget. life will go on. If I was allowed to share materials with students, I'd give you one of my graphing calculators that doesn't have any batteries in it, which wouldn't do you any good anyway. Anybody get an answer? What'd you get, Akash? Okay, so you gotta type in your function, and you'll just use x, comma x, comma lower limit, comma upper limit. That's the kind of thing you're gonna have to know how to do, so don't forget it. Function, comma x, comma lower limit, comma upper limit. Did you get something, Sophie? What'd you get? 0.4? Can you round it to 3 decimals for me? Yeah, I don't know if that's right. Anybody agree with that? Anybody agree with that? Yeah? Yeah? All right. 3 people total got that. That's not very many, right? Better than 0. Is that what everybody got at home in Zoom? Hello? Hello, Zoom?
I put it in wrong. So no.
I got that, yeah.
You got that. Okay, great. All right. Anybody having an issue with their calculator and not know how to put their integral in? Like Akash was. We've solved Akash's problem though, right? Did you get 80.425? Wonderful. That's good. Good news.
Mr. Bachelor.
What?
When I plug it into my calculator, I've been getting different answers, and I switched it to radians too, so I can't really figure out what's going on. Because I have the where you can just plug in the 2 numbers in the equation instead of having to do like the fn comma one value comma another.
Yeah. Did you make sure? Let's see. Be careful with how you write your parentheses. So like, make sure you get the 4y squared over 9 to make sure that just the over 9 is only, on the 4y squared, not with the rest of it. Did you remember your squared? Did you remember your pi out front?
Here, I'll try it again. I'll make sure the bracket everything.
Yeah, I mean, there's no, I mean, this one, it shouldn't even matter if it's radians or degrees. So this one, it should just be, got to be something with how you're typing it in. Just use an x though, don't use a y. You all use an x, right? Just use an x for the variable. Don't try to use a y. The y is, sometimes calculators, I mean, it won't work probably, but the y will have like some value saved in as it if you maybe used it. Yeah? You use the y and it worked. Yeah, so sometimes it might, if you don't already have like a value saved as y, but if you have a value saved as y, which is a possible thing you can do, it will screw it up. Did you get the 80.425 this time?
Mr. Bachelor, I'm having the same problem and I'm not getting it either.
I just got it this time.
You got it right this time. Okay. I mean, the best thing I could say is you could take a picture of what you're typing into your calculator and send it to me in Remind.
Okay, I'll do that.
I mean, I can. Here, hold on 1 second here. While I'm waiting on that picture to come through, so I can try and help her figure out what's wrong. Take a look at this one. Yeah. See if you can set this thing out. We're gonna go around the y-axis here. Let me know when you've sent it, because sometimes like my phone doesn't get great service in the classroom, so it may not go through right away. I'm standing here staring at my phone currently, waiting for the picture though. Yeah.
Yeah, okay.
Okay. Let's see. You've forgotten your square. Did you hear me?
Oh, My bad. Okay, wait. Wait, let me try that because I've done it before and it still wasn't working. So let me try that.
Yeah, other than that, it looks fine. It's just missing that squared outside of the bigger parenthesis before, right before the dx. Otherwise, it looks good to me. Did it work that time?
Yeah, I got it. Thank you.
Perfect. All right. If anybody else is having difficulty, you can always just take a picture and send it to me and remind, and I can look at it. If you're here and having trouble, I'll just come look at it. All right, so we got a new problem up here. We're going to take the region between the x-axis and y equals the natural log of x. And x equals e. And we're going to revolve that region around the y-axis. We're going to get something over here, but this is like three-dimensionally circular going around, right? What a pain, what an annoying looking object. It's like a sort of like a beveled washer or something. Yeah. Just sort of a three-dimensional, like a, I don't know, it's like a quarter of a donut, sort of. That's what I would say. Like you take a donut and you like cut off the whole outer portion of it and then like also the whole bottom portion of it, and you just have like a quarter of a donut but still circling all the way around with the hole in the middle. That's kind of what it looks like. Okay. And we want to find the volume of our weirdly cut quarter of a donut because we're counting calories, right? So we've sliced our donut into like weird shapes or something. Stay on our diet or something. So how are we going to do this? We need to find radius. True? Do we need to find two radii or just one radius? Why two? Because the upper one is larger than the bottom. Okay. Well, let's talk about this one. What axis are we revolving around? Y-axis. Is our region pushed fully up against the y-axis? Is this region all the way up against the y-axis? No. If your region is not all the way up against the axis that you are revolving around, you must get two radii. It's going to be a washer. Right? If I slice this, but if I slice this vertically, or sorry, horizontally, I'm going to have an outer radius and I'm going to have an inner radius. So there's going to be a gap in the middle. Y'all see that there's a gap in the middle if I do that? We're going to get a ring with another ring. Circle. All right, so our outer radius will always be measured from that axis we're revolving around, right? So the furthest right that we go is to
E.
radius is. I mean, this is the rightmost portion of this region is always at x equals e, isn't it? So my outer radius is always going to be e, right? This is just e, no matter what, right? Always e. So we're going to have e squared. What's the inner radius? It's the distance from the y-axis to the function, isn't it? What would that be? What's the distance from the y-axis to the function? It's always x, right? That's x. Well, but since we have to slice it horizontally, we need to figure what that is in terms of y. So if y equals ln x, x equals e to the line. So this inner radius is x, or it's e to the y. This is our inner radius, e to the y. And if I square that, what's e to the y squared? E to the 2y. dy, pi out in front. Where do we integrate from? Left to right or top to bottom, or bottom to top? Bottom to top. What's the bottom of my region? 0. What's the top of my region? It is the y value when x is e. So y equals the natural log of e, that'd be 1. Good? Any questions or issues on that? Everybody here okay with that? A little bit of a difficult setup maybe, but we're okay with it. People at home, are you okay with that or no?
Yeah.
All right. Let's integrate. What's the integral of e squared? Well, e squared is a constant. So if I integrate a constant, I just get that constant times the variable, times y. What about the integral of e to the 2y? Hopefully we can do that one in our head real quickly. It's just a simple u sub. Okay. What does that integrate to? You can use the u sub if you want and write it out, but then you got to separate the two limits and stuff. So if you can do the u sub in your head, that's really convenient here. What is the integral of e to the 2y?
E to the 2y over 2.
E to the 2y over 2. All right, how do we do that? Right, it's e to the 2y that we're integrating, right? So u equals 2y. du is 2 dy. So we'd have to put in a 2 and a 1/2. There we go. Put in a 2 and a 1/2. Okay. And so then when you integrate this, it's 1/2 of the integral of e to the u to the u. Integral of e to the u is e to the u, which is e to the 2y over 2. Everybody good with that? Those are the kinds of ones I'd like you to start doing in your head. So like if it was e to the 3y, what would it come out to be? You're integrating e to the 3y? E to the 3y over 3. If it was e to the 10y, it'd be e to the 10y over 10. Okay. Good? And same with like cosine of 2x. Well, that's 1/2 sine 2x. Right? You integrate the cosine with u, and then you put the 1/2 on it. Helpful to be able to do those in your head. All right, let's evaluate. We have pi times e squared minus 1/2 e squared. You're plugging 1. And then this time, if I plug in 0, I'm going to get minus 0 minus 1/2 of e to the 0, which is just minus. You got to make sure. Oftentimes, people see a 0 as the lower limit and then just ignore it. So like if I plug in 0 for y there, e to the 0 is 1, so I have to use that. Okay. And so we got e squared minus 1/2 e squared plus 1/2 times pi I times 1/2 e squared plus 1/2. Would be our final answer. Good or no? How do we feel about that?
How did you get 1 as the limit again?
It's the largest y value in this region. So the highest point is right here of the region. And that highest point comes when x equals e. So we figured out what is the natural log of e, because that's the height of the function there. The natural log of e is 1. Does that make sense?
Yeah, thank you.
Any other questions? People in Zoom, questions? Let's do another problem. Let's just do a simple one. I'll give you guys an easy one. Let's take y equals x squared. And let's take the region between that y equals x squared and the y-axis. And we're going to revolve it around the y-axis. And we're going to take y equals x squared between that and the y-axis. Let's say we're going to do y equals x squared and the y-axis, and how about y equals 4? So we'll get an upper bound in this region also. Everybody good with that? You guys want to see if you can set this one up on your own? Okay. I'll give you guys a couple minutes here to set it up and try and work through it. Ready? Actually, I'll sketch it first, just so we are sure we're all on the same page. So y equals x squared, the y-axis, and y equals 4. So we're looking at this region going around the y-axis. Okay. So see if you guys can set up the proper integral and evaluate it. So first off, we're revolving this thing around the y-axis, so we're going to get sort of like a bowl-shaped thing. I'm going to write it bowl. And which way are we going to have to slice it? Vertically or horizontally? Horizontally. That's going to give us just discs, right? Because this time our region is fully pushed up against the axis that we're revolving around. Y'all agree with that? So we just need to do pi times the radius squared, and we need to integrate it from 0 to 4, and we got to do it in terms of y because we sliced it horizontally. So what is that radius? It is the distance from here to here is always going to be x, right? So all we have to do is figure out what x is in terms of y. What is x in terms of y?
Y.
The root of y. Everybody agree with that? So we're just looking at square root of y, or y to the 1/2. And then we'll integrate that. Integral of y to the 1/2 ought to be 2/3 y to the 3/2 from 0 to 4. And we've worked on raising numbers to the 3/2 power, right? Yeah. Square root of 4 is 2, and then cube that is 8. So we end up with 8 pi over 3. 0 goes away, right? Is that what you guys got? We're not revolving around the x-axis, revolving around the y-axis. What do you mean? We sliced it horizontally? Yeah. What do you mean? What is it supposed to be? Do what? Because if we slice it this way, we don't get circles. We get some irregularly shaped thing. You have to slice it perpendicularly to the axis you're revolving to get circles. Yeah. Oh, did I forget the square? Pi times radius squared. I forgot to square it. I'm sure glad that I went through all of that. Oh, man. We were having such a good class period, too. I was in a rush because I wanted to do one more problem. Squared. Pi times the radius squared. Integral of y dy from 0 to 4. That's even easier. Y squared over 2 gives us what? 16 over 2 is 8. 8, 5. How's that? Thank you for correcting that stupid mistake.
Mr. Bachelor,
Yeah.
why would it not be the integral of 4 squared minus square root of y squared? Because the whole
that
like
radius, that radius is always however far over we've gone x. The radius is from the y-axis to the function, which is x. What I was going to do, which is why I was in a rush, was I was going to say, what if instead of this region, we talked about this region, and that region that I just highlighted in red there, that would have a radius of 4. Well, it would be 2 squared because you have to go over. It would be 2 squared minus x squared.
Oh, okay, so it's because we're rotating around the y-axis.
Correct. Yeah.
Okay.
We don't have time to do that right now, so we'll do it tomorrow. Apparently, along with the derivatives multiple choice and the free response questions that I asked you guys to work on. How are we feeling about these volume things? Are we feeling okay or no? Okay-ish? Yeah? If there's a volume. Right. If this region is not fully pushed up against there, then you got, yeah, you'll have a gap in there. All right, we're gonna stop there.